Two identical metallic spheres A and B of exactly equal masses are taken. A is given a positive charge Q and B is given an equal negative charge. Before charging, mass of A equals to mass of B. Now the question is, after charging, will the masses remain equal? I want you to think about three of your friends. One is a very good person, the other is somewhat neutral, and the third is a negative person. Now the question is, whom do you want to keep close with? Obviously, you would be close to the positive one, and maybe the neutral one, but definitely try to stay away from the negative one. This is the structure of an atom: electrons, protons, and neutrons. Protons are positively charged and neutrons are neutral, stay together just like a good and a neutral person, and electrons, being negatively charged, stay a little away, revolving in orbits but not close like protons and neutrons. Understanding the basic structure of an atom is crucial in learning electrostatics. For our sphere question, the answer is that after charging, the mass of B will increase. Sphere B was given a negative charge, which means electrons were added to the sphere, which results in increase in mass of B. Think of two jungles, one dense and another thin. Which one can you cross easily? Obviously, the thinner one. Similar is applied for a free electron who wants to roam freely in a material. In a material where electrons are tightly held, it's hard for a free electron to roam freely, just like you in a dense jungle. And where electrons are loosely held, it's easier to roam freely. Think of it as dense jungle equals to insulators, where electrons are tightly held, which means less free electrons, which makes it a bad conductor of electricity, and thin jungle equals to conductors, where electrons are loosely held, which means lots of free electrons, which makes it a good conductor of electricity. Now you have basically understood the structure of atom, conductors, and insulators. Can you guess the voltage of a typical lightning bolt? A 1000 volt, B 10,000 volt, C 1 million volt, or D 100 million volt. Now the next thing is, what is charge and what does it mean by charging? Charge is the fundamental property of any atom or material. Negatively charged simply means the material has excess of electrons, and positively charged simply means the material has less of electrons than protons, or deficit of electrons. Now the question is, how do we charge? We are going to discuss two different methods of charging: charging by contact, charging by induction. Charging by contact. You can simply think of this as something which is contagious, which spreads just via touch. If you bring a positively charged conductor in contact with a neutral conductor, some of the positive charges move to the neutral conductors, making both of them slightly positive, keeping the total charge of the conductor conserved. This is called charge via contact. Simple and easy. Is it necessary to bring the bodies in contact to charge them? No. This is our second method of charging. Consider this. You watched two different movies. One is the most amazing movie you ever watched, and the second is the dullest, most boring movie you ever watched. What will be your mood after watching these movies? You didn't touch or hold the movie, but definitely you felt the effects it had on you. Charging by induction. Similar happens when a charged conductor is brought near another conductor. When a positive charge is brought near the neutral conductor, the negative of the neutral conductor is drawn towards the charge, making one side positive and another side negative. This redistribution of charge is called polarization. You can even cut in the middle to get two small conductors of two different charges. And oh, for the lightning question, the answer is 100 million volts. Grounding. Imagine a large lake or sea. In that sea, you drop a glass of very hot water. The question is, will the temperature of the lake increase? Well, no. Similarly, when a charged conductor is grounded, all the charges surges away to the ground, leaving the net charge on the conductor to be neutral, keeping in mind that we consider the earth to be neutral. This is called grounding. These were the basics of electrostatics. If you have trouble remembering anything, just remember the story behind the concepts. If you liked the video, please share and subscribe, and comment down below which topic would you like to see next. And don't forget to hit the notification button for the next video. Thanks for watching.